everyone, welcome back to SAT Math Question of the Day. This comes from an educator site at the College Board. This question, spoiler alert, this question may appear on a Blue Book test. Okay, in the system of equations below, A and C are constants. If the system of equations has an infinite number of solutions, x and y, what is the value of A? Boy, do they love this question. Because of one, the content, and also because it has to do with parameters in an equation, and the SAT loves equations with parameters in the equations. So let's get right to it. Okay.
Okay, well, let me give you, what I'm going to do is tell you how I figured out the answer, then you go on. Okay, so.
But that may affect the way I'm going to do it. But go ahead.
I don't know.
Go ahead.
So the idea is these two equations will have infinitely many solutions. The only way two equations can have infinitely many solutions is if the left-hand sides, the left-hand side of one is equal to a non-zero multiple of the left-hand side of the other. And so I convert this left-hand side into this form by multiplying both sides by 3, and I get 3 halves x plus y equals, I don't care. And then that's the equivalent of this equation. And then I make the coefficient of y is 1, coefficient of x is 3 halves, so that's it.
Yeah, I mean, I probably would.
And now, depending on the right-hand sides, in this situation, depending on the value of C, there'll either be no solution or an infinitely many solutions.
Right. Yeah.
So, okay, take it over.
Well, I probably would have done a similar thing. I would have noticed that in order to have this type of condition, infinite or no solution, the coefficients in front of the x and the y must be identical. So we have to then. So in order to do that, I'm going to take this ax.
No. The coefficients in front of the x and the y for the top and bottom are not identical.
Seth,
they have to be proportional.
Okay, they have.
What do you mean by identical? What's equal to what?
Okay, after you simplify the equations, then those coefficients must be identical. So just hear me out. So I want this equation to look like this equation. So I'm going to multiply the whole thing by a third because my handle is here. We know this for sure. So I get a over 3x. No. My God, that's stupid. Ax divided by 3 is equal to plus y divided by 3 is equal to c divided by 3. Now I have the y divided by 3's. That's great. Now I have to match this. A over 3 has to match this coefficient, which is a half. See? A over 3, this coefficient here now has to match this coefficient there. So I set a over 3 to be a half, so I solve for a and I get 3 halves. I'm just matching coefficients. It's very similar to how you did it.
I match coefficients also.
Yeah.
But I converted the first equation into the form of the second so that I could do it much more rapidly than you did.
You could make a mistake multiplying this equation by 3. You can, because you could forget to multiply. Actually, it doesn't matter if you forget to multiply the 6 by 3.
That's right.
It doesn't matter. Yeah, but you can make a mistake. This is multiplying of fractions. This is 3 halves x plus y. And then, and then you could just see that a has to equal 3 halves. Yeah, it's really personal choice. My eyes noticed. I noticed something. I noticed a pattern that I want these things to be the same. So I have to do whatever I can to one of these equations to make these things be the same. Seth multiplied the top equation by 3 so that you get a y and a y, a 1y and a 1y. I divided this, I divide the second equation, I multiplied by a third or divided that equation by 3 to get them both to be a third. We ended up with the same answer. And they cleverly put a C in there. So that's vague. It would be interesting if they could have given an answer not possible as one of the choices. It's impossible to find the value of A. That would be the case if C was set up so you get no solutions. But that's interesting. They didn't put the choice in as not possible. If I was writing the test, I would have certainly brought that to the committee as one of the choices.
The logic of the problem includes the hypothesis so that it tells you an assumption.
Yep.
And your goal, your job is to deduce information from this assumption.
Yeah.
Okay.
Right.
So so from this assumption and the other information, you can also calculate what C is.
Of course, that's right.
But they don't tell you to do that.
Right. They don't tell you to do that. Yeah. So, okay. So, that we go through our different questions as we discuss the questions. We could bring up other points. Calculator, of course, there's virtually no way a calculator can help you with this question. Starting with guesses, probably not. Possible, but probably not. Is there a pattern to this? Didn't I say there was a pattern? I don't know. I thought I mentioned a pattern before, but I mean, certainly these things are on top of each other. I don't know if there's any specific pattern to this that makes these specific numbers easier than any other number. How is this different from a school test? Yeah, school tests aren't into as many coefficient questions as the College Board, but you do get teachers who give questions related to what is the coefficient of this and what is the coefficient of that. And of course, in school, it's very important to know the special cases of when you have a system of equations and when you have infinite number, when you have no solutions. And that's essentially what's being asked. That's the main idea that the committee who wrote this question wanted to see if you understand. Under what conditions do you have one solution to a system of two linear equations? Under what conditions do you have an infinite number, and what conditions do you have no solution? And you, as I said in my beginning, you have an infinite or no solutions when, as I say, the coefficients of the x and the y in both equations are the same. Seth said when they're proportional. So Seth is technically right. 2x plus 4y is 10, and x plus 2y is 8. You notice that the coefficients are not identical, but they can be if you divide this equation by 2. If you divide the first equation by 2, you get x plus 2y is equal to 5, and this is x plus 2y is equal to 8. So when you simplify one equation, then you should be able to divide one of the equations by a constant, or actually you could divide by each equation by a certain different constant, and eventually you could simplify them and show them that the coefficients must be equal. Right, Seth? So there's some algebraic manipulations. If you have a system of equations that is infinite or no solution, you should be able to do algebraic manipulations on those equations to eventually show that you can get them so that they would have identical coefficients. Is that right?
I think it's more helpful to look to explain geometrically what the difference. Say if you plot the
Yeah.
lines of the two equations,
Yeah.
you will find that when the two equations have infinitely many solutions, the lines plotting the equations are coincident.
Yeah. Right on top of
And
each
when
other.
the equations have no solutions, then the lines are distinct and parallel.
Right. Right. So
And
that
when two linear equations have one solutions, the lines are non-parallel. And non-parallel lines intersect in one point, and the point where they intersect is it has the solution for its coordinates.
yeah. So that's the graphical approach. Here, the
Yeah.
graphical approach doesn't apply because they're asking you what a coefficient is. But if they give you a system of equations, sure, yeah, you can bring up the Desmos calculator and graph them. And if the graphs look like this, they're completely parallel, then there's no solution. If they are graphing and this one is the first one, and then you graph it and it's right on top of the other one, then there are an infinite number of solutions. And if you graph them and one of them goes like this and one of them goes like that, the other way, or anything, then there's one solution. That's the graphical approach.
So the solutions. What are the infinitely many solutions? The infinitely many solutions are like all the points
Right.
that are all the points, all the infinitely many solutions of the points that are in the line. Right?
So the main idea that they really want to see is whether you understand under what conditions a system of two linear equations has an infinite number of solutions.
Yeah.
So that's about it. I would consider this question relatively straightforward. You just absolutely have to know what what makes a system of equations have an infinite number of solutions. As long as you know that, the question seems pretty straightforward. They considered this a hard question. I don't know if I would consider this a hard question, but this is a very predictable question. You could be virtually guaranteed on the digital SAT there will be a question where
Oh.
you are going to have to figure out something about some constants in an equation. Because as Seth and I have talked about, maybe privately, but we'll reveal our private conversations, this is sometimes you're given the equation and you have to make deductions about its solution or solve it. Sometimes they give you hints about the solution, or they give you the solution and you have to come up with the equation that meets those criteria. So this is that example. Those questions in general are harder conceptually. It's harder to always go backwards, think backwards, but you have to be ready to go both ways with equations. And I think it's time to check the answers. So let's see how they did it. Okay. How did they do it? So we need to condense the discussion just because of the layout of our... So it's a little hard to read, but okay. Choice D is correct. Okay, so we got that. A system of two linear equations has infinite many solutions if one equation is equivalent to the other. Something tells you Seth's not going to like that. Just by the word equivalent. He's going to... Anyway, this means... Well, I can't wait to hear his comments. This means that when the two equations are written in the same form, each coefficient or constant in one equation is equal to the corresponding coefficient or constant in the other. That's what I said. Oh, and the other multiplied by the same number. Oh, right. So then that's the idea of proportional, that the coefficients are proportional. The equations in the given system are written in the same form. Okay. The coefficient of y is equal to the coefficient multiplied by 3. Therefore, the coefficient of x in the second equation must be 3 times the coefficient of the first equation. So they did exactly how you did it. Seth?
Yeah.
They did it almost exactly the way you did it.
Yeah.
Right? So, what is this thing here about equivalent? The equivalent to the other. This means they're defining what equivalent means. Each coefficient or constant in one equation is equal to the corresponding coefficient or constant in the other equation. multiplied by the same number. That's a little confusing. But is that do you agree with that?
Yeah, written in the same form. Yeah,
You agree with
I
it?
think it's clear now.
Okay, great. Okay, so we're done for today. I'm Joel. I have a PhD in mechanical engineering. Seth, my brother, has a PhD in math. We try to meet every day to go over one SAT question that we pulled. Now we're pulling from the educator site. We're only looking at the difficult problems, and we're trying to offer different approaches on how to do these problems. We try to, at some point in our discussion, get to the essence of the problem. What's the main idea? What do you really have to know so that you could apply that to other questions that have a similar main idea? So practice as much as you can. Take all the Blue Book tests. We've heard rumors that Blue Book 4 tests 4 and 6 are the most realistic, at least on the math side, compared to the actual SAT that you can expect. And if you're running into any question, if you're finding there's particular topics that you're a little bit weak on during the practice test, go to the Khan Academy digital course that the College Board is in partnership with the Khan Academy, and go over different practice questions on that are topically related. Like if you want to practice on polynomials, you just take all the polynomial questions and you try to get better. But don't take for granted questions you already know how to do, because you want to practice on those so that you get real fast on those, so you have more time on the few or more than few tough questions that they'll throw at you on the test. So that's it. I think so. I think so. Have a great day. Please give us comments on our videos. We take all our videos very seriously. And if you have any SAT math questions, please email them to us at satmathquestionoftheday@gmail.com. We hope to see you tomorrow. It's Thursday already, and on Thursday we do Throwback Thursday, where we look at a question from an old test from like 20 years ago. Okay, everyone, have a great day.